Alrighty. Today we're talking about complex roots. This is the second half of 2.4. We want to be able to find roots of a polynomial given one of the complex roots. And then we also want to be able to write a polynomial of least degree given the zeros, including complex zeros. So grab your notes and let's get started. Not that. This is what I want. Ender, come on, buddy. Crazy puppy cam. Come on, bud. You're fine. All right. He thinks he heard something, and maybe he did. Anyway, where's the corner? There it is. 2.4, part 2. Complex zeros. Okay. So remembering what a complex number is first, a complex number is anything involving I, the imaginary number, which is the square root of -1. So anything involving I is going to be a complex root or a complex zero. So here's the rule. It's the complex conjugate theorem. If A plus BI is a zero of f of x, then A minus BI is also a zero. Okay, so this is called the conjugate of this. A minus BI and A plus BI are conjugates. So for example, if 2i is a zero, then -2i is also a zero. If 1 minus I is a zero, then 1 plus I is a zero. If 36 minus 42i is a zero, then 36 plus 42i is also a zero. So that's the theme here. If one of these things is a zero, then the other one is too. So if you're only told about one of them being a zero, you can also count on the other one being a zero. So that's kind of nice, especially when we are asked to do things like this. Find the polynomial of least degree with zeros at -4, 1, and 4 plus I. Okay. So you might remember doing this, especially in advanced algebra trig, with just regular zeros without the complex component to it. Now we're adding the complex component in. Or you might have done it with complexes in advanced algebra as well. I'm not sure how far we got on that last year. But at any rate, if these are our zeros, what's one other thing that I can count on being a zero given the complex conjugate theorem? What's my fourth zero going to be? Yes. Knowing that 4 plus I is a zero, that tells me that 4 minus I is also a zero. So we need to account for that as well. So when I'm trying to find the polynomial of least degree with these zeros, what I would do is start by multiplying x plus 4, x minus 1. So that would give me the zeros of -4 and +1. And then I have to do the same thing with the 4 minus I and the 4 plus I. I have to go times x minus 4 plus I times x minus 4 minus I. And keep in mind here that since we're subtracting this, the whole thing here needs to be in parentheses. So the 4 plus I should be in parentheses. The 4 minus I should also be in parentheses until we distribute that negative. Because this was kind of like, you know, x minus negative 4, x minus 1. So it's subtracting whatever the 0 is. So that turned this into a plus. Then we'll also need to distribute the negative here. And personally, what I would go through and multiply first is the two complex pieces. So when I go through and like double distribute and start multiplying stuff here, I would multiply the two complex parts first just to get that out of the way, because once we do that, something really convenient happens with the whole imaginary number thing going away. So first off, I'm going to multiply x minus 4 minus I times x minus 4 plus I, since that's what we get when we distribute the negative to this one here. Okay. So first I'll distribute the x to all of the other terms. So we get x squared minus 4x plus 4I. Then I'm going to distribute the negative 4 to all three terms. So we've got negative 4 times x is negative 4x. Negative 4 times negative 4 is 16. Negative 4 times I is plus 4, or sorry, minus 4I. Then lastly, we distribute the I to all of these terms, or the negative I, excuse me. So negative I times x is minus ix, or xi. Oh, gee. Sorry, guys. This was supposed to be an xi here. My bad. This was supposed to be x times I, not 4. Goodness. All right. Minus ix, and then negative I times negative 4 would be positive 4I. And then negative I times positive I is minus I squared. Okay, so now we have to simplify all of this. So let's see, we have some terms that can cancel out really nicely. First of all, we have minus 4I and plus 4I. Those can cancel. Then we have minus ix and positive xi. That's the same thing, just switched around the order of multiplication, which is okay to do. So xi and negative ix cancel each other out. Then the negative I squared simplifies. Because remember, I is the square root of negative 1. So if I square both sides, I squared is equal to negative 1. So minus I squared would be like minus negative 1, which is like plus 1. So kind of bringing this all together here, we have, let's see, was that a minus or a plus? A minus. Okay. We have x squared. Then we have minus 4x and minus 4x. That's minus 8x. And then we have 16 and minus negative 1. So that's plus 17. So that's what we get when we multiply these two complex parts together. And when you're multiplying complex things like that, you want to make sure you're very careful when you do distributing and everything, and you're simplifying, combining like terms and everything. If you're multiplying numbers like this, where these are the conjugates of one another, when you get done multiplying those things, you should not have any i's left in your equation. If you have any i's left, then something went wrong, and you should go back and double check. So that's kind of a red flag that something went wrong. Okay. Then we're going to take each of these and multiply it into this. So now I'm going to take x plus 4 and multiply it by the, let's see, the x, because the x doesn't get distributed here. If that's what you mean. Only the negative gets distributed because that's kind of like a -1 times this. The x isn't multiplied here. Good question. Okay. So yeah, then we end up with a trinomial here instead of a, like what we're used to multiplying. But anyway, then we take our x plus 4 and we multiply it into this. We're going to go x plus 4 times x squared minus 8x plus 17, which is more like what we're used to multiplying. So multiplying the x by all three, we get x to the third minus 8x squared plus 17x. And then multiplying the 4, we get 4x squared minus 32x. And then 17 times 4 is 68. Then we have to combine our like terms here. So we get x to the third minus 4x squared, since we have minus 8x squared and plus 4x squared. And then minus 15x plus 68. And then we have to deal with our last zero here, the x minus 1, or our last factor here. So we multiply this by the x minus 1. And once we do that and simplify, that will give us our polynomial of least degree with these 4 zeros of -1, 4, 4 plus I, and 4 minus I. Okay, so more multiplication. X first. X times x cubed is x to the fourth. -4x to the third. -15x squared. Plus 68x. And then minus x to the third. Plus 4x squared. Plus 15x. Minus 68. So combining like terms and everything here, we end up with, we have x to the fourth by itself, minus 5x to the third. And if you like to kind of cross things off as you go through and take care of them, you can, just to make sure that we get everything combined. Then we have the x squareds next. So we have -15 and 4. So that'll give me -11 x squared. Then the x's, we have 68 and 15, which is going to give me 83x. And then minus 68 is all by itself. This would be a polynomial of least degree with those 4 zeros. Okay. So the hardest part about this is probably keeping track of everything that you're multiplying together and not making any multiplication errors. Especially when it pertains to multiplying things with complex numbers in them. Okay. Are there any steps that we want to go back to? Any numbers that don't quite make sense or we're not sure where they came from? Anything like that? Yes, so with the zeros, you use the opposite of it. So like, you know, when you're trying to find the zeros after you factored something, and you get x plus 4 and x minus 1 and stuff like that when you factor it, and then you figure out that the zeros are -4 and +1, it's kind of like reverse ordering that. Okay, so let's try another one. and go through it slowly again and see if we can kind of get a better understanding here. Let me find one that said, well, I'll just make one up. And I need another piece of paper. Okay. Okay. This time we're going to do the same thing. We'll have one less zero in there, though. So we're going to find polynomial with, we'll do 3 and 2 minus I as zeros. Okay. So if 3 and 2 minus I are the zeros so far, then that tells me that 2 plus I is also going to be a 0. So we want to have a polynomial with 3, 2 minus I, and 2 plus I as zeros. So now we have to figure out what we're going to multiply together. So on your piece of paper or in your notes, write down the things that you think we will be multiplying together. And once you think you've got them, type done in the chat. Okay. If you chose x minus 3 times x minus parentheses 2 minus I times x minus parentheses 2 plus I, you are correct. And then if you went through and distributed here to get x minus 2 plus I times x minus 2 minus I, you are also correct. So again, don't forget to distribute the negative to both of those. Okay. Then what we want to do is first start by multiplying these two things together, the ones with the complex pieces. We're going to leave this one to the side for a moment. We will multiply this one in after we're done multiplying these. So we're going to go x minus 2 plus I times x minus 2 minus I. So first I'll distribute the x to all the other terms. So we get x times x is x squared. X times negative 2 is minus 2x. X times negative I is negative xi. Why is it always x minus the I values? Because that's what we're doing here with the zeros. For 3 even, it's x minus 3, right? And if you want to think of it this way, if I were to set each of these things individually equal to 0, then x would be equal to 3 in this case, if I set x minus 3 equal to 0. Or if I set this equal to 0, then x would be equal to 2 minus I. Or if I set this equal to 0, then x would be equal to 2 plus I. So it's x minus those, so that those will be zeros of my function. Because that's what's going to make them zeros. Okay. If that kind of makes sense. So for example here, if I were to go x minus 2 plus I equals 0, then I would add this thing to both sides and get x equals 2 plus I as a 0 for my function. So essentially I'm saying, yeah, f of x equals this, because that makes them all zeros, and then I'm simplifying it. I'm multiplying it all out. So we're kind of unfactoring it here. Okay, so then -2 would multiply in next. So -2 times x would be -2x. -2 times -2 would be +4. -2 times I would be plus 2i. Then lastly, we multiply the I through to all of them. So I times x is ix. I times -2 is -2i. And then I times -i is -i squared. Okay. Now we have to simplify. And keep in mind that when we're done simplifying this, there should be no more i's. So -xi can cancel out with +ix. +2i can cancel out with -2i. And then -i squared becomes -1, which is +1. So we get x squared, and then we have -2x and -2x, which is -4x. And then we have +4 plus 1, which is +5. Okay. So we've multiplied the two complex parts. Are there any questions on the multiplying of the complex parts? Anything in here, numbers we're not sure where they came from? We all know where the -i squared came from. Okay. So once we have this, and it's all simplified, then we start multiplying in our real zeros, like x minus 3. X minus 3 is also a factor here, so we're going to multiply that in. And that'll be my last step in this case. So we start x times x squared is x cubed. X times -4x is -4x squared. X times 5 is +5x. -3 times x squared is -3x squared. Times -4x is +12x. And then times 5 is -15. So we simplify things, and then we are all done. So we have x to the third minus 7x squared plus 17x minus 15 for our answer. Okay. So I'm going to show one more example of a type of problem that we can see on our homework today. And then when we're done with that, I'll circle back for anyone who wants more examples. Okay, so the second type of question that we are going to see is find all of the zeros given that blank is a 0. That's going to be the style of question we see next. So we find all zeros given that blank is a 0. So for our example, we're going to say that f of x equals x to the 4th plus 8x to the 3rd plus 16x squared plus 200x minus 225. And we are going to be told that 5i is a 0. (5i) is a 0. Okay. So the first thing we have to notice, if 5i is a 0, then negative 5i is also a 0. And then what we want to do essentially is bring this thing down in degree using these two zeros that we know, so that we can find, so we can figure out what our other zeros will be, what our real zeros will be. So what we want to do for that is use what we learned on Friday with going over synthetic division, or no, sorry, not Friday, Thursday, going over synthetic division to do that. So what I'm going to do for this is I'm going to divide out 5i and negative 5i from my polynomial. So I'm going to divide out 5i, or negative 5i, I'm going to put positive 5i in the box. Doesn't matter which one you start with. You can start with dividing by negative 5i or by positive 5i. Doesn't matter which one goes in the box first. But then I'm going to take my coefficients here. We have 1, 8, 16, 200, and negative 225. So synthetic division with complex numbers gets a little bit messy, especially the first time you do it. The second time you do it, it will look less messy. And we'll see what I mean by that in a moment. So step 1, bring down the 1. 5i times 1 is 5i. Here's the part that gets difficult. When I go to add these, I cannot add them because they are not like terms. I can't add 8 plus 5i and get anything that's like one single meaningful number. So instead, I just have to write 8 plus 5i. So then, when I go to multiply by this 5i here, I have to do some distributing. So I have to go 5i times 8 plus 5i. So down here, I'm just going to do some work that allows me to continue on up here. So we distribute. 5i times 8 is 40i. 5i times 5i is plus 25i squared. Now keep in mind, I squared is negative 1. So this is really a negative 25 here. So we get negative 25 plus 40i for our simplified version of multiplying these two things. So this is what's going to go right here. Negative 25 plus 40i. Then I have to add again. And wouldn't you know, we're not going to have everything be like terms, so it's going to end up with a very similar situation to right here. The 16 and the negative 25 can be combined. So we do get 16 minus 25 is negative 9 plus 40i. Okay. Then we got to do what we did here again. Multiply the 5i by this right here. I'm going to switch colors. So we got to go 5i times negative 9 plus 40i. So we get negative 45i. And then 5 times 40 is 200, so plus 200i squared. But then remember, I squared is just negative 1. So this is really negative 200 minus 45i. So that's what's going to go right here, negative 200 minus 45i. So when I go to add these, this is something nice. 200 plus negative 200 is 0. So we're left with just negative 45i right here. Then we go negative 45i times 5i. And we get negative 225i squared, which is equal to positive 225. So that's what goes here, 225. So if it helps to kind of separate things here, you can. Adding these together, we get 0, as we should if this 5i is indeed a 0 of our polynomial. Okay. So now I'm going to do synthetic division one more time with these as my new coefficients and negative 5i in the box. So over here, I'm going to take these and keep them as my coefficients, and negative 5i is going to be in the box. We have 1, we have 8 plus 5i, we have negative 9 plus 40i, and we have negative 45i. So I just directly transfer these to be my new coefficients. Okay, and here's where we're going to see things work out rather nicely. So first we bring down the 1. 1 times negative 5i is negative 5i. Well, that's really nice because 8 plus 5i plus negative 5i just gives me 8. Then we go 8 times negative 5i, and that gives us negative 40i. Which works out really nicely because then the i's go away here as well, and we just get negative 9. And then negative 9 times negative 5i gives me positive 45i, and adding down here we get 0. Okay. So now here's the part that we need to be careful with. When I go to put my x's back in here, we notice that we divided two times. We divided this polynomial twice. So instead of starting with x to the 3rd power here, I'm going to start with x squared, because x squared would reflect me dividing this twice. So we have 1x squared plus 8x minus 9 is what we are left with. So now I just need to find the zeros of this. And we can do that by factoring. We can do that by looking at the graph. I'm going to factor this because it factors really nicely into x plus 9 times x minus 1. So a list of all of my zeros here for my final answer. We have negative 9, positive 1, 5i, and negative 5i for my zeros. Okay. So again, kind of going back and recapping this one. First, we were told that 5i is a 0. So then we also know negative 5i is a 0. So I put 5i in the corner and take my coefficients, and I synthetically divide, making sure that we're careful when we multiply by 5i and when we add and subtract like terms. Then I take these same coefficients down here that I got, and I'm going to divide this time the negative 5i in the corner with my same coefficients from down here. We go through and divide, and we get something with no more i's in it. So another clue that when you get down to the end, you should not have any i's left in your equation at all, since we've divided out a complex number and its complex conjugate. And so then at the end, we get our polynomial. We find the zeros by factoring or by graphing. And then we put down our real zeros and our complex zeros as a complete list of all the zeros. Any questions from this one? Anything we want to go back to? If it comes out to just a number, like, let's see. If you're simplifying the i's out and it comes out to just a number. Oh, the IXL starts with some pretty simple ones, so it's likely that it could be just a number for your answer. Yeah, IXL starts out with a lot simpler than the ones that the book starts out with. So yeah, let's see. Yeah, we'll take a look at a couple IXL problems too and talk about some of their ones that are more on that level of complexity. Good question. Okay. On a scale of 1 to 5, 1 being I'm completely lost, 5 being give me the homework now, how are we feeling about this? Okay, solid. So for those of you who would like your homework now, I will post it. It is 1 IXL section, D7, to a smart score of 80. For those of you who would like to stick around and do a couple of examples or go through a couple of the IXL questions with me, stick around and we will do that real quick. The rest of you are free to go work on the assignment. I will post the exit ticket in a couple minutes as well. Have a wonderful Monday.